This is an AMIGA power supply and it's broken. Hello everyone and welcome back to Arctic Retro. So I got this AMIGA power supply which is broken. I got it as a donation and yeah, I thought I'll take a look at it, see if I can figure out what's wrong. If I can't figure that out, I am gonna build a new one. So yeah, let's see about that. I have several AMIGA machines, several AMIGA 500s, 1200 and a 600. However, I only got one working AMIGA power supply and that's this one. So I'm really in need for yeah, at least one more. And this one, which is working, is quite heavy. It's made in Western Germany. So quite heavy version. However, this one, it says made in Taiwan and it's really light. I mean, it's less than half the weight of the other, but it is the same specs. And it is a little bit beaten up. You see broken off plastics here and there. It's not working. I have tested it. There's no voltage from it. So I'm gonna open it up now and just take a brief look at it. I just want to take the opportunity to thank my sponsor PCB Way. They are very friendly people and they also make very nice PCBs for affordable prices and very fast delivery times. So if you need to have produced your own PCBs, then you should visit PCBway.com, and these are some examples that they made for me. And all of these you will find on their shared project site on PCBway.com. Right now they are hosting their 5th PCB design contest. And if you design PCBs yourself, you should definitely participate to win nice prizes. Also take a look at their other services like CNC machining, 3D printing, sheet metal fabrication and injection molding. You find everything on PCBway.com. This power supply is rated with input voltage 220 to 240 volts, 50 Hz, 80 watts. Output is 5 volts at 4.3 amps and 12 volts at 1 amp and minus 12 volt at 0.1 amp. And even though this is much lighter than this one, and this one is actually rated for higher power than this one. And this one only provides maximum 2.5 amps at 5 volts. Yeah, and this was 4.3 amps. So yeah, that's quite a difference. So I'm not an expert on power supplies. However, I can measure basic stuff and try to figure out what is wrong. And as I said, if I can't figure it out, then I'll probably build a new one, a new power supply. And I already got the parts for that. So I might build it anyway, even if this is working. Yeah, there it is. Just as a precaution, I do not recommend you work on power supplies if you don't know what you're doing, because it can be really dangerous. You can get a shock and you can kill yourself. Don't want to have that on me. There's a couple of screws down on the PCB. So I guess the reason this is so much lighter is because this is a switching power supply, while the other one is a much less efficient and heavier linear power supply. The first thing I'm gonna do is just to do a visual inspection to see if I can see anything wrong, and of course measure this fuse. The fuse is good. No, I can't really see anything wrong here except this little chip. It is quite corroded, looks like rust on this side. Otherwise everything looks to be okay. Capacitors are looking good, but it is full of dust. I'm gonna blow it free of its dust and do a little bit of cleaning. But most probably it's some component that is broken. So then it's just a matter of figuring out which. I'm just gonna check this switch. Oh, it's off. Switch is good. So I looked through this and I can't really see anything wrong here. So no bad solder joints that I can observe at least. Now here's the dangerous part. I have turned it on now and I'm just measuring a little bit around. So this seems to be the ground going here. This is the high voltage side and this is the secondary low voltage side. Yeah, you have this transformer here. Without schematics it's hard to know what's what, but at least there is almost 150 volts there. That seems to be alright. However, on this side I get nothing. This is ground over here and yeah, so that's ground. There's nothing on the output of this side of the transformer. But then again, I'm pretty clueless on how this actually works and what I'm actually gonna try to observe here. Yeah, it's rusted and seems to be rust on this power transistor or whatever it is. Seems to be a lot of corrosion on these components. They're all black. And oh, look at that. Okay, there's something. That Zener diode, it's actually corroded off. Gonna measure with diode mode, see if this one, for example, has any. I got no reaction at all. Okay, on this side I can see that it has a voltage drop of 0.56. And that is probably correct. Yeah, 0.51, so those are good. But definitely that one is an issue. Not really sure what type it is, the rating and things like that. So to find that, you actually need the schematics. I'm not really sure if I can read it off the actual component. It's so small. So I think there's actually been some heat here because since these are so black and it's like they have been burnt. Yeah, alright, I give up this for now. In this video I'm not gonna try and repair it. Instead I'm gonna build a new one. But I'm actually gonna use some of the parts from this, and the parts I'm gonna use is the wires, of course, and this switch, I think. But the actual power supply I'm gonna replace with this one. This is a MeanWell PT-65, and it has the correct specifications for both input voltage and outputs. It has 5 volts and plus and minus 12, and it can provide enough power. It's up to 65 watts. That should be plenty enough, and this is brand new. I got this from DigiKey. I think I paid like 25 or 30 euros / dollars for it. So I've been thinking a little bit, should I use these covers? I don't think so. I mean, it probably fits, but yeah. This is ugly, it's big and bulky, it's damaged, not very nice. So I'm gonna ditch this, I'm gonna make my own case. And it actually doesn't fit, even though it's smaller than the old one. The old one has these indentations that makes it fit around the screw fastenings. I searched around a little bit for cases for power supplies for the AMIGA, and I actually found this one on the Thingiverse. And this is actually made for the exact same power supply that I have, the PT-65. And it's a little bit smaller, and yeah, looks to be a very nice one. It has the wires both coming in on the same side. And it has cut out for the same type of switch. Okay, so I'm gonna print this. I'm gonna start with printing this part here and just check if everything fits before I waste more plastic. And it takes some hours. Yeah, I actually sliced the part here, and it has an AMIGA logo on the bottom, and it with the fast setting, which is not that accurate, it takes 3 hours and 10 minutes to print this part, and the other part takes about the same time, so total of 6 to 7 hours. Let's start printing then. The first part came out really nice. As I mentioned, I didn't print on the best setting, so this is a little bit less accurate, but it's good enough for these larger things. So yeah, let's see now if this fits with the holes. There's 4 holes, one in each corner on the PCB. Yes, that's perfect. And then the switch on the side, I actually found a white one. Maybe I'm gonna use that. Yeah, it's the same kind, fits nicely there. However, these cable retainers here, they don't fit because this model has a round hole for that, and yeah, the inside here is square. But that I'm just gonna fix by filing it out, cutting a little bit, and then it should fit perfectly. If you make your own cables, you can of course buy these cable restrainer or retainers that are round. And the model actually had instructions and what kind of part and where to find it for those. So now I'm just gonna print the other part. And I actually made a small modification to it. As you can see, I printed Arctic Retro in 3D letters on the side. So yeah, and yeah, that's something you can do when you download these models. It's easy to modify them if you need to. And this part on the 0.35mm fast mode, it's gonna take 2 hours and 44 minutes. When you print a 3D model like this, you use a program called a slicer, and what it does, it takes the model that you have and splits it into all the different layers that the printer prints. So here we can see the different layers. It starts with the first layer like that, and then layer for layer it just builds up the whole thing until it's finished with the last layer and the model is finished printing. While I'm waiting for that print to finish, I was thinking maybe I should take a further look on this old power supply, see if I can fix it by replacing that little Zener diode that's broken off. I'm not really sure if I have a replacement. I'm going to take it out and measure it and see if I can figure out what it is. It's out. So I searched around the internet a lot for information about this power supply and the schematics. Couldn't really find anything. I found the schematics for an AMIGA power supply with the exact same model number, but it looked completely different inside. So yeah, this Zener diode seems to work. It's not shorted and it's not open on that in that direction either. So it has a voltage drop of 0.74 volts. I'm gonna try and find a Zener diode that has the same value and see if it works. I can't really see anything on the label. I tried to magnify it as much as possible, but I couldn't really see what's on it. I found some diodes here. Let's see now. Oops, other way around. You know, diodes, they block the current in one direction. And then there's some threshold values. Yeah, and this has the same voltage drop, but it might still not be the same. But I'm gonna try it. Let us see what happens. So what could happen if this is the wrong value? I don't know. Maybe it explodes and catches fire and my house burns down. But I'll take my chances. No, I don't think anything will happen. Maybe if that Zener diode is too low rated, and it might just burn out. Let's turn it on. Yeah, nothing happened. So let's see now, does it work? Nope. 12 volt is still dead, and I think here's the 5 volts. Oh, there's 2 volts there. No, that was too easy, but it was worth a try. The bottom of the case is now finished, and yeah, it looks nice with my own little logo here. I take no credit for this, obviously, but this is just a label telling that this is my power supply. Alright, so I'm giving up on this one. It might be fun trying to fix it, but it's an old one, probably unreliable. If I fix one thing, maybe it will still not work, and yeah, it's better with a new, more modern one. So just cutting these wires, and then I'm gonna reuse them. So this is the new power supply, and now I just need to figure out how to arrange the cables. This is the primary side, and yeah, the live and the neutral comes in here, and the ground, I guess, is that one. Yeah, there's a ground symbol there. However, the switch is going on the other side, so I need to make a longer wire for that. Now, to get these wires to fit, this one, the power input wires, I can just cut them a little bit shorter, and I will crimp on a connector, and then the switch goes over here. But for the DC wire, it's a little bit different. It has to go all the way over here, and the wires are not long enough, and I need to move this cable retainer, and I don't know if it's glued on or melted on. I think it can turn. There is a space between, so I'm gonna try with some heat and see if it loosens up, and I can move it back here so that the wires can reach. So I need to be a little bit careful here. I don't want to melt this cable, and yeah, we'll see how it goes. If it's glue between, then the glue will perhaps loosen up. Let's see now. It's hot. No, it won't budge. Oh, it's hot. It kind of turns up here, but not down below here. Okay, so with a little additional heat and some force, it actually came loose, and I can pull it back to my mark there. So when it cools down, maybe it will grip on and stay there, I don't know. Yeah, no, that sits very firmly there, good enough. I can't easily move it. Okay, it's time to start making the contacts and attaching the wires, and I'm going to start with the AC input cable. Before I start connecting up the power supply, I need to check the data sheet, and here's the MeanWell website, and here's the power supply, and yeah, here's the data sheet, and here's all the specifications, and here is the different pinouts for the two connectors. So pin 1 is neutral, pin 2 is live, and grounding is required. And it says what kind of housing and terminal you're going to use for the connectors. And on the DC output connector, it says pin 1 is V2, pin 2 and 3 is +5, pin 4 and 5 is common, that's the ground. Pin 6 is V3, so we need to figure out what's V2 and V3, but I need to be sure about that. If you're interested in where to find this power supply, I went to DigiKey, and it's PT-65B. Here's the DigiKey part number. It's 1866-3929ND. And the price was, including VAT, 310 NOK, which is about 32 euros or dollars. I'll start with a ground wire, and I'm using this 1.5 millimeter red crimp-on terminal. And that goes onto the ground pin there. Then it's the Molex for the live and neutral, and it's this kind of housing that has this, yeah, I'm not really sure what to call it, but it has this plastic sticking out that keeps it down and clips in with the contact. But we need to attach the switch. There's no need for a fuse because there's already a fuse here on the power supply. Then for the live and neutral, I'm using this terminal here that goes into the Molex connector, and yeah, it goes like that. And for that you need a crimp-on tool like this. I'm not really sure if this is the correct tool, but it will probably work. This tool is meant for smaller terminals, but I think I can just do it twice, one on the outer part. But not gonna push it all the way down, because this is meant for smaller wires. Yeah, and then the inner part that grips the actual wire. Yeah, that looks all right. Let me zoom in. Yeah, I think that's pretty solid. The brown wire, which is going to the switch, I'm gonna solder. And of course we need a little heat shrink onto this to isolate the soldering. So that went through. I just use my soldering iron to heat it up. And I use a larger one over that. Then we have the switch. I already removed the old stubs of the wires that were there, and just gonna push it through the hole and bend it like that and solder it in. Yeah, that looks solid. I'm gonna check that we didn't damage the switch. Nothing. And then turn it on. Yeah, and it's on. Alright, so the live side is finished. That's how it goes in. Let's see now if we can start this up. I haven't tested if it's actually working. Hopefully it is, since it's brand new. So now the switch goes all the way over here. So it will be like this. Could have shortened this wire a bit, but yeah, just gonna leave it like that. I hooked it up and I'm gonna turn it on, and now this becomes dangerous because it's live, so better not to touch any wires. So let's see if we get any good voltages. No, 4 and 5 should be the common. There's no markings. Yeah, there's ground there. There are markings on the PCB. Then we should have -12 on this one. Yeah, -12. That's also ground, and 5.1 and 5.1 and 12. Yeah, so this works as expected. Now it's time to make the other side, and this is the DC wires, and yeah, 2 of the wires are thicker, this red and black. I guess that's the common, and that's the 5 volts, which has more current, and these are 12 and -12. So there's actually 6 wires, but there's only 5 pins in the contact, so I guess one of those is the actual casing around that's grounded. So I measured out all the wires with the multimeter, and the white one is the -12 volts, pin 5. The casing and the pin 2 is yellow. The thick red is as expected 5 volts plus, pin 1. The black is as expected ground, pin 4. The brown is the plus 12 volts. And the thin red is actually connected to the thick red, and also 5 volts. So now I'm just gonna crimp on a terminal on each of these wires. Alright, that was it. I think these are really well crimped on. Yeah, it looks like that. Now somehow I did manage to order the wrong housing for the connector. It has these plastic blocks on the side, and yeah, that won't go down into the connector, so I'm just gonna cut those off. Yeah, that works. So now it's just a matter of finding the correct placement, and yeah, the ground was this 4 and 5, and pin 6 was the -12 volts, so that's the white. The 2 reds are 2 and 3, and the yellow is ground, and the brown is plus 12 volts, so that's pin 1. And the yellow goes into there. Alright, that's finished. Let's see if it's correct. I've turned the thing on now. Let's measure here and see if we find anything interesting. Since the shield ground is the same as the ground, we can use that. And Actually, on the back side of the original power supply, there's diagram of the connector and the pins. So pin 4 is ground, and yeah, let's see, pin 1 is 5 volts. Yep, and pin 5 should be minus 12. Yep, pin 3 should be plus 12. Yep, so that seems to be correct. Pin 2 should be ground. Yeah, it's correct. And pin 4 should be signal ground. So yeah, 0, that's correct. All right, I think this is done now. Only thing left to do now is to organize these wires a bit and put the whole thing together. But these holes need to be square, so I'm just gonna use a Dremel and yeah, just cut out that the width is actually fine. It just needs to be square. Just cut a little bit on the other part as well. So let's see now, does it fit? A little bit tight around these, but I cut away some more material. Let's see now. Yeah, that fits. Then we need 4 screws for this. I'm not really sure what kind of screws I'm gonna use. I'm gonna try with these. See if this grips. No, nothing much happened. So they need to be longer because they go through the PCB. Oh, I already got screws. These are the old screws for the old power supply. I can just use those. Yeah, that fits perfectly. Okay, the power supply is finished and it looks very nice. You can see that it's 3D printed, obviously, since I didn't use the best quality, but I don't care about that. Switch is perhaps a little loose, but it can't come out, so it's safe. This looks okay. The fit of the top and the bottom is not perfect, but I think it's good enough. I'm ready to test the power supply on a real computer, but first I'm gonna clean off these yeah, old cables. It is quite white and quite different than the original AMIGA grayish color. I might paint this. I don't have plastic that looks like an original AMIGA, but this will have to do. Let's see if it works now with this AMIGA 500. I'm gonna use an old 500 to test with first. Yep, seems to work fine. Well, I kind of expected that, but you never know. I could have mistaken the pins and yeah, connected it up the wrong way. Everything can happen, as I have learned before. So, can it power up this a little bit more valuable machine, an AMIGA 1200? It's a little beaten up, but I'm gonna pretty soon make a video where I do some restoration about this. It doesn't have a floppy disk drive in it, so, but at least we can see if it shows the kickstart screen. Yeah, and there you go. It works. Alright, there you have it, how to make your own AMIGA power supply with relatively cheap parts and modern parts. And if you don't have an old power supply that you can use the cables from, you can get cables everywhere, and you can also find that square DIN connector on eBay. I recently searched for it and I found it. Wasn't expensive at all. So it's good to have a modern power supply. This is the one I'm gonna use from now on, and the old one is gonna have a rest. And yeah, I think that's a good idea. You never know what can happen with those old power supplies. They can either start failing, or they might produce voltages that can damage your computer. And this old power supply, I'm gonna send it off to my friend Kjell at Koiro Retro Innovations. I'm pretty sure that he can figure out what's wrong with it and repair it, and yeah, we'll see what happens in the future with this. So that was it for this video. I hope you enjoyed it, and please hit that subscribe and the like button. And a special thanks goes out to my patrons. See you, bye bye.